to the Funtastic Academy. Today we are going to learn about electrolysis. What's that? You'll find out. Now, we need to answer the quiz question from last video that I did not forget about this time. The quiz question is, who was the oldest person to ever win the Nobel Prize? The answer is John B. Goodenough. That is his actual name. He won the prize in 2019 for chemistry, in particular for his work in developing the lithium-ion battery. So, now you know the answer, we can get on for the show. So, what is electrolysis? How does it work? And how does it relate to splitting water in half? So, what is electrolysis and how does it work? Well, electrolysis is a way of splitting a liquid into its component elements. Now, you're probably thinking, only liquids? That doesn't sound pretty useful. Sometimes I want to split solids too. Remember though, you can always just melt the solids, separate them, and then cool down later. So you can really separate anything you want. So anyway, we're going to use the most common liquid there is as an example, water. So this is my totally real glass of water. Now, the way electrolysis works is that you have a simple battery right here. This is the symbol for battery in circuits. And then the battery continues down into two rods. Okay, so these are the two rods which are dipped into the water. First, this is the negative rod, which is called the cathode. And this is the positive rod, which is called the anode. So cathode and anode. Great. Now the battery is connected here, right? So we are supplying charge to these two rods. Now, nothing's happening yet. What's wrong? Well, we need to add something to this water to make it conduct electricity. This something can be anything from salt to sulfuric acid. But anyway, once we've added it, charge will start flowing. Positive charge will build up on the anode and negative charge on the cathode. Now what is water? H2O, right? So that means it has one oxygen and two hydrogens. They're arranged like this. Now, the oxygen has a negative charge. It's a negative ion. And that means it's called an anion. Wait, negative is C, right? So it should be cation, right? In electricity, everything is reversed. Now the hydrogens have a positive charge. They should be called anions, but because everything's reversed, they're called cations. So, this has a negative charge and this has a positive charge. Now, what happens over here? Over here, on the positive end? Well, the negative oxygen loses some of its electrons and it oxidizes. So you get some pure oxygen coming out of here, the anode, and a few other ions. On the negative end, however, reduction happens. What this means is that the positive hydrogen gain a few electrons and you get pure hydrogen gas plus a few electrons. Remember the words oxidation and reduction. They come up a lot through chemistry. So, oxygen loses its electrons and oxidizes the anode. Hydrogen gains electrons and reduces at the cathode. So, we've been using the example example of oxygen and hydrogen throughout this episode. But you can use anything really. As long as the salt or sulfuric acid you added doesn't interfere in anything, the oxygen will oxidize out and the hydrogen will reduce. Now, because there are 2 hydrogens to 1 oxygen, these get produced in a 1:2 ratio of hydrogen and oxygen. So, that is how electrolysis works. Now, don't you think it's a bit hard to understand? Well, a smart guy called Michael Faraday taught too. Remember that name, Faraday? He'll come up later in a later episode. Anyways, Faraday made 2 simple laws governing electrolysis. What are they? Let's find out. Now this board is magically clean, so I can write Faraday's laws on them. Now, here's the first law that he made. If you double the power of the battery, then you double the amount of hydrogen and oxygen you collect. In fancy science terms, the voltage which passes through the electrolyte and the amount of substance collected are directly proportional. But you don't need to understand that. You just need to understand this. Anyway, his second law is a bit more complicated. Now, I said oxygen is negative, right? It has more electrons and protons. It actually has 2 more electrons and protons. So we write O2 minus. Now, Faraday's second law says, if we just had O1 minus instead, we would have 2 times the amount of hydrogen and oxygen. Why? Well, because the amount of work you have to put in to neutralize the oxygen is twice as lower. But if you had O4 minus, well, you would have half the amount of oxygen which would be collected. In fancy science language again, the ionic charge on the substance and the amount of substance collected are inversely proportional. These 2 laws allow us to understand electrolysis, along with a third thing you need to know. That thing is the electrochemical equivalent. Basically, if you put 1 volt of charge to a particular liquid like water, how much hydrogen and oxygen will you collect? That's the electrochemical equivalent of that liquid. So, using these 2 laws and the electrochemical equivalent of a liquid, you could figure out exactly how much gas you collect. Now, let's recap what we learned about electrolysis. We learned about oxidation and reduction reactions, and we learned how electricity can be used to split molecules. So, now that you know about electrolysis, here's a quiz question. Again, you have to research about this. What is a Hoffman voltmeter? Tell me the